What's up, man?
Not too much. How are you?
Happy Friday.
Happy
I'm
Friday.
doing good. My voice is a little bit raw, but I think it's going to be all right. I was in Florida and I went to Halloween Horror Nights with my nieces and we screamed a lot. And then I went to Disney on the next day with Epcot with the rest of my family. So it was pretty fun.
Nice.
We went on this roller coaster at Halloween Horror Nights. It's called the Riptide Hollywood Rip and Roll roller coaster. Have you ever been on that?
No, I don't. What is Halloween Horror Nights?
Halloween. Oh, right. You're not a Floridian. Sorry. So Universal Studios every year they do this thing for Halloween where they go to the park and they make it Halloween themed. They have a bunch of haunted houses. They hire a bunch of actors to like dress up in like crazy costumes, and then they go around and find like all of the high 15 to 18-year-old girls and make them scare them the entire time because they're like the easy ones. So I was with my nieces who are teenagers and my girlfriend who is not 15 but scares as easily as a 15-year-old. And they just got targeted all night. So you just go through these haunted houses and all the rides are decorated. And there's like smoke everywhere and scary music playing. It's a pretty good time.
You like that stuff, right? Like the haunted
I
house.
love it. I was
Yeah.
laughing the whole time. They were like digging their fingers into my arms.
I'm with them, by the way. My wife was like, "Oh, she sent me this thing to like a haunted car wash." And I was like, "Absolutely not."
I love that stuff. But yeah, man, it was good. But back at it now, excited to get back to work. And we had an interesting conversation this week about useActionState. So we want to riff on that a little bit today.
Yeah. Yeah. I guess before we get into that, I think we kind of talked about this last week, but there's this like idea like why we use React, why we choose React. Yeah, I think like before you kind of get into like the abstract stuff of use action state, it's cool to just remind ourselves like why we chose React and then how these new hooks like kind of reinforce that choice or help us with that choice. So as we said last week, we have data, and that data we have to display that data in a UI. So the data comes from a database, it comes from somewhere, but we got to display that data in the UI, and then we're all making interactive UIs, whether it's like forms or even more interactive stuff like Canvas and all that. But eventually we need the UI to update as data changes. So if I'm filling out a form and I click save, or I read an email, I expect like the unread email count to go down by one somewhere else on the screen. And React is amazing because with React, our UI is a function of state. So we get the state, which we're just going to imagine is like the data in a database. And then we're able to describe the UI in terms of that state. So if I read an email and I archive it, I don't have to describe how to decrement the number from like 100 to 99. I just say that the number is the count of unread emails, and then when I set an email to read, that number goes down by one. And this matters because when you have to describe how to do it, you start introducing bugs. One of my favorite examples of this is you think of like a form, and like a form can be in like a valid state or an error state. And when it's in a error state, the text boxes turn red. They get a red border around them, whatever. They show an error message. When you go from the valid state to the error state, it's pretty easy to like describe how to do that, right? Find all the inputs on this page, iterate over them, and add the error class. And then the opposite is also true. Find all the inputs on this page, iterate over them, remove the error class. React doesn't make you do like describe the how. You just say when the form is in an error state, apply like it's like a ternary in JSX. Class name equals is error. Pass in your error class, otherwise empty string. That's easy, and it's hard to describe like why you need React with this example. But then someone comes along to you and says, we have a new state for the form. It's a warning state. And when the form is in a warning state, we need to show like this data, make it yellow or orange, not red. And so the how is actually becomes a lot harder, because the how, you now have to describe how to go from valid to warning or error. You have to describe how to go from error to valid or warning, and then finally from warning to error or valid. So even though you only have 6 states, even though you only have
You have
3
three
states, you have
states,
3 states, you have 6 ways you can move
six
between
transitions.
6 transitions, 6 ways to move between those states. So now just iterating over all the elements and adding and removing classes gets to be a little bit harder. Maybe it's still doable.
It's way harder because now when you add error, do you have to remove warning or do you have to remove valid?
Exactly. But with React, it doesn't get harder. It's just
Right.
another if. It's just another ternary expression.
It's
If
like O of N
Yeah,
complexity. If you add a new state, you have to just describe the UI for that state. Whereas with imperative code, adding a state literally doubles it. It's like not linear O of it's not a linear complexity. It's
it's like
not
exponential.
exponential. Yeah, exponential. It's some function or squared or something like that, and you have to account for that in your code.
Yep. And too, just like as someone that has um, before I used React and these modern kind
As
of
an old
UI
gray
tools.
beard,
Yeah, exactly. It's someone that's been around the block. Still not good, but it's someone that's been around the block. No, we used Backbone for a while. In Backbone, you would describe the transitions, and it was great. But then it was great, and it felt really powerful because you were writing JavaScript, and then when events happened, you were able to like reach into the DOM and update things, show warning labels, show error labels. But you would constantly get these like bug reports, and you never really thought about, oh yeah, what happens if you like code the happy path? You code from like valid to warning to error, but you never really thought about what happens if you go from error to valid to warning. And then like someone reports that bug and you see it, and then with React, this class of bug disappears. This idea of declarative rendering. And by the way, I want to give like a 30-second intro of like why we chose React.
no, it's good.
And I'm already like
It's a
6
good.
minutes in.
It's good setting the stage because it's related to what we're going to talk about.
Yeah. So anyway, I just wanted to.
It's not. It's not even just the class of bug goes away. It's the entire space of concern,
mental space.
the mental space, and the concerns in the code goes away. You literally don't code those things.
You never think in React, what happens if I go from valid to error to warning? You're just like, no, the state is warning, so I know that these are going to be the classes that show up. Yeah.
I love this form example. It's a good little minimal example of how adding state doubles the complexity of the of the transitions of the different flows between. Basically, every time you add a new state, that's a nice example.
Yeah. Yep. So now we get to start to make the abstract leaps.
We love abstract leaps
We
on
love
this
abstract leaps
podcast.
here. Yeah. Okay. So I've been playing with the useActionState, and yeah, it's an awesome hook. And I don't know. I feel like I've been using it on and off for the last year or so, and it kind of just hit me this last week why this hook exists, why we need it. Yeah, and I kind of want to walk through like I want to compare two React apps, and I want to start with a React app that's just like purely a client-side React app that doesn't talk to a backend, doesn't have a backend. It's like it's a type of React app maybe that you're going to a coding boot camp and you're going to teach someone React. This is the type of thing you want to teach them. We're just going to stay in React. We're not going to introduce a server or databases or anything like that because, yeah, you want to keep like the teaching area small for someone that's new. So you make a to-do app. You show them a to-do app. You can add to-dos. You can check off to-dos as complete. You can remove to-dos. But all that entire app is just in React state. So if you reload the page, you lose everything. But you can start to learn React really well building an app like that. And then sort of like the next module in this coding bootcamp is, well, we're going to learn about backends and databases, and API requests. And so we're going to take all this data, and as you enter it into the form, the to-dos, we're going to persist them to a database. And there's a lot of really weird stuff. We go from like 0 to 60 or to 100. I don't know when this happens. So the first thing is like you go to save a to-do in the client side React only app. And like as soon as you click save, that state is immediately updated and the next render happens. Now I know with like concurrent mode, there could be, just like as a caveat here, like with concurrent mode, there could be like CPU block stuff, there's transitions, there's all this, but I just from more from a just how you think about client only React, like you call set state, the next render is going to contain that state. As soon as you introduce a database, like we're now making a fetch request. That's async. So I make a fetch request to save a to-do, and the next render isn't going to have that to-do is like status saved, because I have to wait for, also, I don't know if I said this, but we've moved out of the client only React app, and I'm not talking about the React. Okay.
Yep.
Yeah, when you call set, when you make a fetch request to set like is completed true, you don't have a guarantee that is completed is going to be true on the next render. Like someone could add a counter to that page and just do increment count +1, and that count is going to go from 1 to 2 and 2 to 3, but we're not going to see like is completed is true until the API request comes back. Let's use some state around our API request. Let's say that while we're saving, we set is saving to true. We make a fetch request to go complete the to-do, and then we await that, and then after that,
Are we completing it to do or adding it? Let's just stick with one. Let's just do completing it to do.
Okay, completing it to do.
Okay.
Yeah.
Yep. Mm-hmm. So now we have some pending state, and we have some is pending saving state. Is true.
Yep. So we've got like is saving is true, or is completing is true, whatever.
Is saving is true. A fetch request to set the complete to true in the server.
Yep. And then we set the complete. We set is saving to false after we await the fetch after that. So now, and then you use that is saving to like style loading spinner or some UI, and you get immediate feedback. Like when I click save, that spinner is going to be there as long as the fetch request is out. But there's something kind of interesting here where this is where we go from like that 0 to 100. Mm-hmm. What happens if I click the complete button twice, like really fast? I just go complete. And like, do I have 2 requests going out? I guess I do. I have 2 requests going out. Are they both going out to set like the same value? Or are they going to toggle the value? Like what's the deal with them? And if I have 2 requests going out, should I like keep track of the requests? So like maybe something as simple as like you can't click the button while the request is in flight. I disable the button. But like, do I need to like, yeah, what happens if the first one comes back? The first one goes out, sets is saving to true. The second one goes out, sets is saving to true. The first one comes back, sets is saving to false. The second one is still saving. It hasn't come back yet. But in our React state, we've set is saving to false.
It's interesting because all of a sudden you are now thinking exactly about the kinds of problems we talked about in the beginning with the forms.
Yeah. You're thinking about like
what the current state is and how do I get to where I'm going? And where I get to where I'm going is based off the previous state, the current state, and I don't know what that is. And when I add another interaction, I exponentiate the amount of paths through the code. And now all of this stuff that React helped remove from our heads has come back.
And it's it's so much simpler when there's no like async code. It's just so much simpler. There's so many buttons you can add to a to-do app that like aren't like adding a to-do, completing a to, deleting a to-do. And the fact that like any one of those can be clicked at any time and you don't know which other ones have been clicked before your click. And if you were to do all that bookkeeping yourself, like, first of all, that it fills the mental space. You're no longer writing a to-do app. You're just like keeping track of outgoing Ajax requests and just it's outgoing fetch requests. It gets, yeah, it just gets gnarly. Um, so this is where use action state comes in. Use action state, yeah, it gives you the the how should I think of this? It gives you a place to do remote mutation, and it gives you like a guaranteed order, so that as you fire off those actions, as you make changes to remote data, like sending a fetch request, it's going to update is completed to true in a database somewhere. You know everything that happened before and things that happen after. So if you mash the button like 10 times, you know the first one is going to fire first, the second one's going to fire second, the third one won't fire until the second one completes. And so you get back to the space of there's not ever two outgoing Ajax requests, fetch
There's
requests.
no possibility for your code to, without use action state, your code can move from the first request is pending, the second request is pending, the second request is complete, and the request is complete. Or it can go pending, pending, and then first one completes first, second one completes second. So just with two button presses in a normal React app with two outgoing requests, just because you added this line await fetch, await has basically forked your program. Any line that says await, you now have a fork. And the fork is exactly like the forms case where you have the fork because you have to understand whether you're in a warning or a valid before removing the right class to go to error. Now it's exactly the same thing. And so when the code comes back, it matters if the first request completed or the second one did. And use action state removes that. It's not
Yes.
possible. It can't happen. So the order of events, the order of your actions are going to be the same. So just like adding the await forked your program, putting the await back into action state collapses it back down.
Beautifully said. Beautifully. Um, okay, when you're writing client side only React, you don't have any servers or anything. There's something so nice about knowing that when you set state, that state is coming. It's just going to come flow back through the UI in the next render. If I click a button that sets state count +1, and then I click a button that says set state count +1 again, then I know it's going to go from 1 to 2 and 2 to 3. I know it's not going to go from like 1 to 3 to 2. You know what I
Right.
mean? I just know
Right.
that it's not even something you think about. Use
Right.
action state gives you that same confidence with remote network requests.
Right.
So, and specifically remote network requests that like will modify state that you would see in a
Right.
form. So
Right.
yeah, yeah,
Okay, so there's more that we want to unpack here because that was great. I love this example of like the analogy to client side React and how the virtual DOM basically does that imperative work for us. The virtual DOM takes care of saying the new rendered tree is warning. What's the current rendered tree? Okay, I need to remove the valid class or I need to remove the error class. That's what the virtual DOM let us do. And React's model of always re-render from state. So now let's take my example from my React Conf talk where you add to cart, and then check out. It's the same thing. You just want to describe what happens, and you don't want to have to think about the request coming back. So,
oftentimes,
or
oftentimes when I would use action state, I would like run some. I would take a server action on the server, and I would just try to wrap it and use action state. So like the state of my of use action state would just be whatever my server action returned. And use action state, it works like a reducer, so it passes in the previous value as well as like the current action. In my case, for like the forms I was building, there was no previous value. The notion of a previous value didn't make sense to me, so that was always null. And then what was a current action? Well, I was only using it when I was like submitting forms. So the current action was like a form data object. And it always felt to me like a lot of wiring. Like I'm wiring up a function that takes previous and form data. I only ever want form data. Um, and then I like return some new state out of this action. And then I read that state in the UI and update it. But like this whole idea of previous just never made sense. Why do I need the previous value? Like I'm, let's take your add to cart thing.
Mm-hmm.
If I click add item to cart, and checkout, why do I ever need the previous state? Like I just you add two items and then you check out. So like I never understood. Why you would need previous, and it was I guess that the thing that made me kind of realize this was the fact that it's like asynchronous. You want to get all your events in order. If you said earlier, you might have an event that depends on what would happen before it, and previous allows you to look into that. And this idea of like enqueuing and always running your events in order. So
Okay, so when useActionState came out, why did people start using it? It was used to be useFormState, and I'm trying to remember like the original motivation for when people would first reach for it, how they talked about it when it first came out.
yeah, it would you knew a form if you had something with use action state, you could know that a form was submitting with use form status. So that was
Right.
kind of like a nice little pair.
Right.
So that was yeah.
So thinking about the add to cart case, in normal React, let's like think about the client side example. You click add to cart and you just increase it by 1. So your click handler is going to be set count plus 1. So in that sense, it depends on the previous state. That's what the button's doing, even in a pure client side app. Now, there's this question that gets introduced when you move to the network that says when the user click adds to cart twice in a row, and you're saying set count equal to count plus 1, is it the count in the database at the time they click the button? Is it the count in the UI? What do they mean? And when you do all this yourself, this is where all of these different forked paths through your app make it hard. And what transitions is trying, what useActionState is trying to do is bring back the mental model from the client side only version, where you can just do your logic and only think of the before and after, and all the other stuff doesn't matter. So when you add to cart,
Well, what's a classic problem that is on all checkout
right,
sites?
right. So what happens when you add to cart, kind of in React async today before useActionState, and this is similar to what I showed in my demo at the talk, is first you can click it multiple times, and if they just come back and update the screen, just think about what can happen. The happy path is 1, 2, 3, and then those requests come back in order, and you see the count go up by 1, 2, 3. Let's ignore the latency just for a second, I guess. Like, ignore the UI, but just think about the logic of it. What else can happen? 1 can succeed, 2 can fail, 3 can succeed. What else can happen? 2 can succeed first, 1 can fail, 3 can succeed after that. Think about all of those possibilities you've introduced, and especially if it depends on the order. For example, click liking a tweet. If I like a tweet, we can all just step back from all this technical discussion, look at the user using the UI, and know exactly what they want to do, especially when we have an optimistic, like an immediate feedback in the UI. When you like a tweet, it toggles immediately. How can it toggle immediately in the UI if all 9 of these possibilities are real? This is one of the problems useActionState's designed to solve. So by default, when you use ActionState and you have something like liking a tweet, it puts them on top of each other. It plays the logic of it back in order. It's almost like packet ordering in HTTP, where like what is TCP IP is an improvement upon DNS because DNS packets can arrive out of order.
UDP.
UDP. UDP, but you wouldn't get it. I would make a joke about UDP, but you wouldn't get it. So TCP/IP improves upon UDP because the UDP protocol sends packets, but it doesn't make guarantees about order or duplicates or even receiving them. TCP/IP protocol improves upon it by adding layers to the protocol that can do things like retries. If it fails, it will stop it. It won't send you an out of order packet, and HTTP builds on that. That's obviously a good abstraction from the sense that not nearly all the time when I'm sending a message from one computer to another, I want it to go in order. And if message 2 doesn't work, I don't want message 3 to succeed. Think about texting someone and you send 3 texts, but the second one doesn't work. Do you want the third text to go out? Maybe it's really important that it doesn't. So all of these kinds of cases are actually the same problem that we're dealing with here with liking a tweet from a React app to a server. And so if what useActionState does is it collapses all of that vector space of possibilities into 1, 2, 3. That's it.
The UDP TCP thing is really nice, and the text message thing is really nice because, like, yeah, you're adding 3 items to a cart, and the second one fails. Like, what does it mean to add the third one? Like, really, what does it mean? Are you adding the second one again? Are you adding a new third one? It's hard to answer. You have to answer that when you're dealing with this. So, yeah, I really like the text message ordering here.
So this led to another conversation that we had, which is related to some of the confusion around useActionState that we had when it came out, and still just some of the confusion because, it's a new API. There's not a ton of examples. And that is this like entanglement and queuing stuff. So if you are used to writing apps in React that make fetch requests, let's say you have 3 to-dos and you click the bubble to complete them. And while it's pending, it shows a spinner. And then once it comes back, it flips. If you just have an on-click handler and you run an async function and you do that, you'll see the 3 pending, and then those 3 pendings will go away as soon as each one of them come back. Let's say that each row is like a to-do component, has its own state, is pending state, and it handles the fetch request. When you start learning about actions in React 19, and then you use ActionState to get the pending feedback, and you do this, what you notice is that even if the first and second request had finished, if the third one is still pending, the first 2 are still going to be pending as well. And this is kind of like, why does this happen? And the reason is partially because of what we just talked about, which is the goal of useActionState is to capture like the intent of the user in your code in a way that doesn't add extra unnecessary states. And so if the user pressed complete, the fact that the fetch request return may be out of order, it's almost like we just want to translate those 3 actions into the output, like into what should happen in the code. And so when you call useActionState, by convention, you get 3 arguments, and they call by convention state, action, and is pending. And the action part that returns and that you wire up to your forms or whatever is what's confusing, because people are used to just calling functions, but when you call this action, all of a sudden it's like entangled with all other pending actions. And so we had this discussion that maybe it would be easier to understand if this was called enqueue, right? Just kind of conceptually, just think about this for a second. If it was called enqueue, first of all, they'll be very clear that they're going to play in order, in the order in which they happen. Second, it's nice to it's almost like you're having a better understanding of what React is helping you with here. You have a queue, and now I can say, what is React going to do if the second thing in the queue fails, right? We're not going to continue on with a third one. What are we going to do? Another point is exactly your point, which is the previous state thing. If you think about all 9 of these possibilities, then there's plenty of situations where, like adding a cart or liking a tweet, you actually do care about the order in which it happened because you have to know whether the current tweet is liked or not in order to toggle it. Use action state gives you the previous state as an argument. And because it's really enqueuing them, you always know that the previous state to the second request is going to be the response from the first request. There's no other, you could not get that guarantee if you write this code yourself, unless you wrote like a ton of code, right?
Yeah.
But that's just not even how we're used to thinking about it.
Can I interject? It's almost like when you set state in React, you know that your next render is going to have that value of the state.
Exactly.
In the same way, when you use action state, you know that the previous is going to be the last value, and it's never a question of I ran 3 requests, which request is in previous. It was a one before you. It was anyway.
Exactly. Yeah, the set state thing is really interesting too, because set state is really enqueuing a render.
Yeah.
When you call set state, and this is something when you first learn React, it's confusing. It's like a top question in Stack Overflow. It's like stale closure. Why is this stale value stale? Because I called set state and I tried to use the new count in the next line, but the count is referencing the closure value, which is stale. In fact, it's not stale because you are in the current render. And the way you start to understand how React is designed to work is to think of set state as something that is enqueuing a future render, right? When you call set state, you're not mutating things that are used today. You're enqueuing what the value should be for tomorrow. And in the same way, the action from useActionState is really like the same idea. You don't want to think anymore about firing off requests and re-rendering. You want to think about enqueuing the state for tomorrow. The thing about tomorrow in this case is that because of latency, because of the network, React wants to kind of like create this bomb shelter and just put your app in a pending state. And so that's what happens when you use action state. You are enqueuing requests 1, 2, and 3, and the entire time your app is in transition, and that lets React discard it if something new happens, lets the app stay responsive, and again, without you having to think about how do I navigate away from this page if I'm in between request 1 and 2? Or how do I toggle this drop down if I'm in between requests 2 and 3? All those sorts of bugs. I hit add to cart, but it was out of stock. And so my checkout thing is all of those kinds of things. It's trying to solve the same problem. It's trying to give us the same mental model for our async code. And you enqueue these 3 things. Your app is in transition. They come back in order, and then your app settles. And one of the beautiful things about this is how it plays with other hooks like use optimistic and use deferred value, because now that React knows your app is in transition, you can use optimistic, for example, to do the liking button on Twitter. And that way you can show immediate feedback. But again, the likes will go in order, and the correct intention of whatever the user did in the UI will be carried across. And how do you get from the pending state to the settled state? React does that for you. And again, just like in the case where we have 9 different paths, and now they've all settled, so I have to know, do I need to remove this class or that class? I have to think about where I'm at. You don't have to think about that. It collapses it all down, and that's like the goal of this whole thing.
Yep. Thanks for bringing up use optimistic, because we're talking about like, oh, look at all these benefits you get when you queue up these outgoing requests. But someone might say like, yeah, but like if request 1 and request 2 don't depend on the same thing, maybe also too, if they don't depend on the same thing, they probably shouldn't be in the same use action state. So that's
Right.
that's like one way to just solve this. But someone might just say, I don't want queuing. I just want to fire and forget. I want to fire and forget and not deal with this. Well, that's what use optimistic lets you do. Use optimistic just says, okay, this request is going out. We have it enqueued, but we're going to give you a place where you can immediately update state right now, so it can immediately show in the UI. So use optimistic is like, it's a very nice counter to like, I don't want queuing. I don't want the queuing behavior of use
Right.
action state.
Right. There's something else here from some of the conversation we've been having around the related data stuff, because I felt like we had a light bulb moment there a couple of days
Yeah.
ago. I think part of the confusion around use action state is also because the previous state argument and the way it's talked about sometimes in the docs or in materials is that it's like a reducer, right?
Mm-hmm.
And it basically is a reducer in the sense that it is a function that receives the previous return value of the previously submitted invocation of that action. And that's good because you can use it to, set data based on the previous data. But reducer, the word reducer, like has a lot of baggage, and well, it's a loaded term. Let's put it like that. It's a loaded term, and reducer came from Redux, and there's use reducer in React now, and reducers in React aren't really like I was going to say they're not really fundamental, because when you're teaching React, you can get very, very far without ever talking about a reducer. So I argue that they're not actually fundamental to the mental model of React. Now, it turns out useState is implemented with use reducer under the hood, but that's not really what I'm talking about here. I'm talking about the mental model of how like everything we've been talking about, frames of rendering, set state is enqueuing a future render. But we have this hook, use reducer. And what is use reducer for? Let's actually pull up the docs for it. If you go to react.dev and you look up use reducer, it says use reducer lets you add a reducer. And it says, let's see, usage. Writing reducer functions. There's something in here I want to find, which is like, where's it say? Okay. Extracting state logic into a reducer to learn more. So this is part of learning managing state. It says components with many state updates spread across many event handlers can get overwhelming. For these cases, you can consolidate all the state update logic outside your component in a single function called a reducer. Okay, so the reason use reducer exists as an API in userland in React is because when you call set state and you add more and more states to your app code can get confusing. Not because we've introduced the imperative stuff again, but because you are adding state that could be derived from each other. It just literally gets confusing. The clarity of the code goes down. It's hard to understand. And so you can imagine this is like, the data is null and the state is pending. The data is null, error is an object, and the state is error. Data is an object, error is null, and the state is success. If you write these with like 3 different state variables, you're going to end up doing a lot of like setting state of multiple values of state that are related to each other, and it's easy to like miss a case.
And React won't stop you if you set data to true.
Exactly.
Is pending to true and error to true, something like that.
Exactly.
React cannot stop you from that.
Exactly. So this is the point of use reducer being a userland hook. It lets you put related data, related state together and make changes together so that it's easier to reason about and make sure you avoid situations like the one you just talked about. So people say use action state is a reducer. But the thing is, the reason use action state exists is not for the reasons we just talked about. It does not exist to help reduce the complexity of new state that you have a hard time managing in your mind. The reason use action state exists is for the enqueuing behavior we just talked about. The fundamental reason this exists is because without it, you have to think about these 9 different paths. With it, we get to put our app in transition and think about it in order. Again, the TCP/IP UDP example. And that is the reason. That's the reason it exists. Mm-hmm. And so, Yeah, I think that that was just something we talked about with like the reducer stuff and how you can use reducers on the client and it's kind of like a reducer over the network. I think this kind of language is not really helpful because it doesn't really get at a lot of the benefits of it.
Yeah. I think the queuing is a big benefit. I think there are some, like, I think you can kind of twist it. I want to try to convince you that the reducing fact is really
Mm-hmm.
nice. I want to start with
Mm-hmm.
this
Mm-hmm.
example. And,
Mm-hmm.
um, okay, you have a checkout form and you're making a shopping cart and you click add item, checkout. And we're dealing with a really slow server, but you just click that really fast. You're like, you come in, you know what you want, add, checkout. Um, in the happy path, all the two items that you added are available. And the checkout, like you have enough money in your account, your credit card is working. So the happy path is those things get queued. So we add item one, then we add item two, and then we do a checkout. And uh, when checkout runs, it gets a previous state. And so it can look at the two items you added and it can say, okay, you added two items, they look good. I'm gonna continue with the checkout. And it goes through. Now there's a version of this, the same thing, but item two isn't available. So now you go add item, checkout. No network requests have been made because you've gone so fast, but they're in queued. And we see a little loading spinner. Maybe we do some optimistic UI. It says, Sam, your items are on the way. Uh, Item one gets added. So we return some state from useActionState that says item one is in the cart.
Item two
The
fails.
item two fails. So now we return some state from
That says
useActionState
error.
that says item one is in the cart. Item two is in the cart, but it failed. And then we go to run checkout. And we're running checkout and we check the two items and we see that item two was not in the cart. So when we're running checkout, we actually don't send a network request to your server to complete the checkout. When we're running the checkout code inside that reducer, we
Mm-hmm.
say, listen, normally we'd be able to fire off a server action right here and complete the checkout. But because item two failed, we are just going to return like previous state. We're going to pretend that we never even tried to complete this checkout.
Mm-hmm.
And so now your state is item one was added, item two is out of stock, and then you get that in your UI and you can
Right.
decide what to do.
Right.
So the
Right. Right.
fact that
Right.
we got this previous state allowed like our reducer, and I agree with you. It is not about like collapsing state, but it
Yes.
is.
Let
But
me.
yeah,
It can be useful. I think we should talk more about this example after, like maybe next time we get some chance to play with it. But I 100% agree. There's some cases we've been talking about where like the code in use action state depends on previous state, and it makes a lot of sense. Which is something that all of us have had a hard time finding examples of, and it's not in the docs anywhere.
yep,
So let me rephrase. Let me modify what I said earlier, and just point out that it's not that there's maybe there's benefits to having a reducer and writing the logic of your actions in a way that's derived from previous state. But the reason you reach for use action state is not the reason you reach for use reducer.
yeah,
That's what I wanted to actually
yes,
say. And that's what I think is confusing because use action state is talked about as a reducer, but the motivating factor for you getting it is to use previous state in your UI, to use a return value after a transition settled, not to base it off of, not about related state. Like you could have one piece of state and you just want to use the return value, like let's say log in from an action and you just want to know if it error or not. It's just a single piece of state. Like this, like the state is literally a string.
hmm
This is not about reducing complexity that arises from multiple pieces of state interacting with each other. So the first reason you probably are going to reach for use action state is because you want to use the state in your UI. You want to know if the action is pending, right? And maybe you want to compose it with like another action or something like that. So all of those motivations have nothing to do with the motivations for switching from use state to use reducer.
right,
So I think that that is confusing. I'd like to see that like clarified. And also the action terminology versus enqueue. I think the enqueue word really gets at a lot of the motivations that you're going to have when you first reach for it. You're going to
Yep.
be firing off actions. They're going to be coming all over the place. They're operating on related state. And so enqueuing is a way to solve that. So maybe that is an example where actually these network requests are modifying related things, and the first network request affects the logic of the second. Maybe they
Yeah.
operate on the same state. That's when you want to reach for it. So it is about related state. So maybe walking back a third time, the reason you reach for reducer instead of state is because you're dealing with related state, and managing all of that is complicated. The reason you reach for use action state is because you have lots of actions going out concurrently in all sorts of orders and coming back in different states and at different times, and they operate on related data. For example, liking a tweet, unliking a tweet, and liking a tweet. They're all related because it's the same tweet, and that's when you want to reach for use action state. So I guess the thing here is like it's more about the complexity of the network that's inherent rather than the complexity that comes out from code you've written.
Yes. I would say just if you were to observe how I write code, if I'm wiring up actions to a form, I'm always using use action state.
Right. Exactly.
If I'm not always using use reducer. I use use reducer twice a year. If that.
Exactly.
I'm mostly using use state. So
exactly.
So I definitely do agree with that. And yeah, I think it's because in a client-side React app that has no network, you can get away with using use state because you set state and then you get a next render with that state.
There's no in between.
There's no in between. Once you introduce asynchronousy, you now need like the reducer part is really important as well as the queuing part. Well, I guess the reducer part is really important. How do you get the user? How do you get the reducer?
How do you provide an API that lets you only use a reducer so that you only have to think about previous state and you can return the new state? You have to queue.
You have to queue. Yep. And this was
like part of the unlock.
This was the unlock for me. And there's so much. Write a form I think the checkout form is really good. You add items and then you try to complete a checkout, and it doesn't matter at what point you click the buttons and when the AJAX requests go out, you can get that working. So you click the button, AJAX request, click the button, AJAX request, or click, fetch. The order of those doesn't matter. The reducer is going to always behave the same, which is awesome. Right. Just for me, doing things like a form where you can save the form, you can reset the form to the initial state, as well as you can refresh the form. So if the form is out of sync with what's on the server, you can click refresh and it returns the latest data on the server.
Right.
So there's a lot of like, yeah, I think forms are really good for this hook. Like there's a lot of actions you want to take. Different actions.
It did used to be called use form state for a reason, right? I think the other thing is like when I think the hook was first introduced and people were experimenting with it in Next, the previous state idea was confusing because if you're telling me I'm going to like a tweet 3 times, I'm going to send a fetch request and I'm going to change the liked value in the database. I'm not using the data from the client to do that. I'm in my API handler for toggle tweet.
Exactly.
I am looking at what's in the database. I'm not trusting what's in the client. I'm of course looking at the database to change it, or let's say adding stock, right? But the toggling is interesting because the action depends on the previous state. So I think the toggling is actually interesting. However, there is an interesting thing here, which is that while you're going to read from the database what the current liked is true or not before changing it to false. It's nice that you know what the user saw when they pressed the button.
Yeah.
Because that's what previous state gives you.
Dude,
what's the use case that we just talked about?
Wait, hold on. Let's stay on this tweet thing because there's so many weird again, there's so many weird wrenches you can throw in this. You're saying you have an API endpoint and you read from the database and then toggle the tweet value, right? That's what I would do.
Mm-hmm.
The user clicks the tweet button 3 times, but they're in a really bad internet connection. 2 of them go out. 1 of them fails. What's the state of the tweet?
Mm-hmm.
It's hard
Mm-hmm.
to like what's if you're doing optimistic in the UI, like
Mm-hmm.
you have to go off and like verify that optimistic it's just hard to answer. But if you know that they're in order, and let's say the first one works, the second one fails, you can decide what to do for the third one.
Mm-hmm.
Because the second one can return a piece of state that says like I didn't toggle it, I didn't
Right.
switch it because it failed.
Right. What was the example that just came up on Twitter like within the last month where it was like an input with previous state where I'm trying to remember who talked about it. We'll have to follow up on this and talk about it next week. I thought there was something with like an input. We had also talked about the sync example is nice because in the case of the like tweet, the database is a source of truth. So obviously you want to use that to know what the final value is. But capturing the intent of the user is important too. It's too abstract to talk about. So we'll have to come up with a good simplified example. But think about doing back to the To-Do app. You can add a to-do, delete an old one, reorder it, and then add it. And you can see how, first of all, enqueuing is important here because there's a lot of things that could happen in between of those 4 requests. And if you reorder it, but the user's reordering something that is not reflected in the database yet, you want to capture the intent because when they reordered it, they wanted to set it before this thing, right? But if this thing haven't saved yet, you wouldn't know, and you can't just So that's a great example. I think that's a good example. It'd be fun to work on some of this for sure.
Right. Just that I think I knew what you were saying. You go to add a to-do item and then you immediately go to reorder it, and your reorder API endpoint or server action expects like a to-do ID and a position so it can put it in the right order. But if you fire that before the save completed, if you fire that before the save completed, you don't have a to-do. So you need these things to happen in order.
Interesting.
This is, again, back to how we started the podcast, that you have to think about all the in-between. You have to think about all the transitions. What happens if I reorder and it hasn't been saved? And useActionState eliminates that. And the way it does that is by you treat it as a reducer that keeps modifying this shared piece of state.
Right. Or not necessarily just shared piece of state, related state. So when I create a to-do, it matters if the previous to-do was deleted because the position is going to be different if it is. So it's about it's about mutating related data and making sure all those updates flow back to your app in a way that's as simple as it is when you're in client side. Cool, man. I'm excited about this. There's a lot. I feel like there needs to be so much more documentation here.
Oh, they're done. I was thinking my thought on this was like a gallery and just a gallery of like, here's how you do a multi-step form, like with like, 3 different pages. Here's how you do something with like a really slow network. Here's what happens if you increase the speed of the network. And you can kind of see that like none of your code should change when that happens.
Nice.
I will say this too, that it's been like hard to realize this stuff and unpack it. And I kind of feel like for the past week, I like go on, like I kind of start following a path and I'm like, oh no, that didn't work. Like I got to rewind it. I do feel since I like landed on this like reducer style, and again, it's not about a reducer in the use reducer sense, but in this idea that you have state, you're sending some command or you're dispatching some action that's going to modify that state, and you're going to keep doing this loop over and over again, dispatching and modifying. I feel like since I landed on this, every form looks like this, and I haven't run into any problems, which I think is really nice. So I have a form where
You've been working on your open graph.
This was one thing I was working on. Yeah, I have a open.graphing is a little thing I put together.
OpenGraph.ing.
OpenGraph.ing. The little app I put together shows OG cards for your website, and I added a feedback form to it, so you can send me an email just when stuff breaks. And there's like if you send a message and then you close a modal. I'm using one of those. I'm using headless UI, which keeps the modal rendered underneath, so they can like animate it up. It's beautiful. It's beautiful. When you reopen the modal, like you have to reset the form if it was still there. I guess I could like key it. That's one way to do it.
Right.
But yeah, just thinking about like the states of this form, how it resets. Are you resetting if you're sending feedback, if like feedback is in flight, just all that. And all that kind of went away when I started doing useActionState.
Interesting.
I did a demo of like a multi-page thing, and it's really nice because like when you're on page 2 or page 3, you kind of start with an empty, your state is like an empty form, and then page 1 fills out like the first 3 questions, page 2 fills out the next 3, and so on. So you kind of can derive where you are. Your state can be derived from what questions you've answered,
right?
Or your page. And then this morning I did a rollback form, and I'm making a YouTube video about this.
Oh, cool.
So you can save a form, and then you can roll it back to a previous value from your save. And first of all, when I did Rails, if you ever want to do rollback, if you ever want to scale a Ruby on Rails developer, tell them they needed to add undo to a form. Because what that looks like is saving giant JSON blobs in a database.
Yeah.
And then somehow getting the server like to go back to a certain value.
Yep.
Dude, with
HTTP is stateless.
With useActionState, you have state. With useActionState,
with a client app, you have state.
So you have state.
With useActionState, you have access to the previous submission. You can literally push it onto an array.
That's exactly what I do. I have a history array. I push it on there, and then rollback.
That's crazy.
Rollback, you just call the reducer with type rollback, and you look at the previous one, and just set that, and then you send it to the back end. So, and also too, order really matters here. Order really matters here.
Yeah.
Because if I do save rollback, that's very different from save roll. Also, I should say order matters not. When I say order matters, it's not order from when the user clicks in the UI. The order is the order that the server receives.
The server code is running.
And the way you guarantee that order is with this queuing.
Yeah.
The same way the text message example you gave, the
same way HTTP.
TCP.
Yep. TCP. Yep.
So if I fire off a bunch of random requests and they're not in useActionState, and I do save rollback, that does not mean my server is going to receive save rollback. It might receive save rollback save, and then you're just like, wait, the thing that's in the database is the thing you've tried to roll back.
Right.
So to use useActionState,
nice.
It's save, wait for completion, save, wait for completion, roll back, wait for completion. And then I don't do this in the video. Maybe this should be like a follow-up, but you get to layer in use optimistic. So even though the thing is queued under the hood, you can immediately show feedback to the user. And so it's just so beautiful. It reminds me of writing client-side React.
Right.
When I keep going back to this, but when I call set state in client-side React, I just know that the next render is going to have that state.
Dude, totally. If you use optimistic, you can click rollback, and then you can start editing again and do a new thing. So
before the server has even seen a single request.
Exactly.
Yeah.
And the server's going to get the right value once you. Yes.
This is a thing that blew my mind about useActionState. It's like you can turn off your internet or bring your internet really slow.
Yes.
And it doesn't matter. The order of the actions that you take in the browser is always going to be the same. Like you edit a form, you roll back a form, you edit the form. But the order that the server gets it is going to be in a different order.
All right.
But it doesn't matter because useActionState is going to guarantee that the order that the reducer was run in is the same order that the server is going to get any server actions you invoke inside of that reducer.
Right. It's awesome. I need to play with it some more. I'm looking forward to your video, man. Let's get it out before this podcast goes up so we can link it.
Cool. Yes, let's do it. I'm gonna Yeah, it's a lot, but I'm having a blast coding this stuff. It's one of those things where I made a feedback form and I got this all working, and then, just like, oh, there's so many examples that I can do with this and just want to teach them. So yes.
Yeah. Cool, man. Love to hear it. All right, let's wrap it up for this week. We'll talk to you all next week. Thanks for listening. And have a great week.
Cool. See ya.
Bye.